All right, very good. So, as I've been saying for the past while, we've been running through the plethora of spring finest NGC's objects on Alan Dyer's list, which appears in the Observer's Handbook every year. And there's some real gems in there. I mean, some of them are brighter than some of the Messier objects, so it's really worth a look at them. And I'm going to actually highlight some that I'm going to refer to as kind of showpieces, which I think are particularly good to look at. Because there are so many to get through in the spring sky, I'm not doing them in any kind of particular order, but I have picked a group of a set of them for this session, which are kind of in a related patch of the sky, so they'd be all right. So we're looking at least in the latitude of Toronto, you know, we're looking at the end of astronomical twilight at 11:15 p.m. So that's dark. That's late for it to get dark, but hopefully folks are able to kind of catch a nap and get up late and look at some of these great objects in the sky. The other thing is that because we're dealing with springtime objects technically, but because if you pick ones that are northerly, have a northerly declination, then they tend to remain perched on high a little bit deeper into the season. So even though we're getting towards the end of spring, a number of these are still definitely observable after dusk once it gets dark in the evening sky during this time of June. So first up, I'm going to actually highlight this group here. I'm going to show you where they kind of all are to start with. So we're looking at a group of objects that are kind of on the meridian. You like to choose things while they're relatively close to the meridian, because that way they're going to be higher in the sky and then more easily seen through Earth's blanket of atmosphere. And, you know, even though it's not technically fully dark until about 11:15, I mean, you can start looking at these objects, perhaps some of them as early as around 10:30, and maybe even a bit later, though, if you're living in a more northerly city. But certainly this time of the night is certainly fine. First up, I'm going to mention one of these showpiece objects, and I'm going to actually direct you to this one earlier in the evening. So right as soon as it's astronomical twilight's done. That's NGC 5746, which is also known as the Blade and Pearl or Sombrero Galaxy. That's this one right here. And what I love about this one, and I've written about this in Sky News before, is that it's so easy to find. So it's a great galaxy. There is no picture for it in Stellarium at the moment. So you will need to activate your DSS option to pick it up. And there you go. Look at that fantastic kind of flying saucer shape. So it's Stephen O'Meara, the American author Stephen O'Meara, who actually coined the notion of the blade and pearl. He's talking about the core of the galaxy being kind of stellar, and he's imagining it as a pearl balanced on the blade of a sword or the blade of a knife. So that's where he gets it from. Also called the Mini Sombrero, because it does resemble the Sombrero Galaxy. So it's an intermediate spiral. It's bright enough to see with, say, 4-inch or larger aperture telescopes, discovered by William Herschel back on February 24th of 1786, number 126 of his Class 1 objects. And look, it's just 20 arc minutes due west of the star 109 Virginis. So I'm going to turn off this and wind back out so you can see what I'm talking about. So here we've got Leo and Nebula. We've got the bright star Arcturus. We've got the figure of Virgo the Maiden beneath her, and her more northerly foot star is 109 Virginis. And once you've got that, you'll find that these are actually, let me turn this back on, depending on the telescope and the eyepiece combination used, they'll share the field of view. So this is a simulated view of a 6-inch Dobsonian telescope using, and let me just put on the 26 millimeter colossal. So that's about a 35 power field of view, about a 1.5 degree field of view. And you can see you're going to have that bright star in the field kind of interfering with the dimmer galaxy. So what we recommend, of course, is that once you've got the field located, going up and choose a higher power so that you're able to hide the bright star outside of the field of view. So once you've got this view, you want to use your averted vision, try some various magnifications. You can look for the galaxy's shape, its orientation, see if you can see the pearl in the blade, that sort of thing. Describe the core and the halo characteristics. Look for these field stars. There's some neat field stars, beneath it. And if you've got a larger aperture telescope, then you have a hope of extending, the range or the length of the blade, so to speak. Also, you want to look for another galaxy in the neighborhood. Let me just wind back a little bit. Go to the previous ocular. There's actually a little galaxy here, NGC 5740, a little spiral galaxy. So they all three share the field of view, but you want to hide the star out of the field. So that's the NGC 5746. All right, next up, turn off these to declutter a little bit. Now we're going to go a little bit more north, and we're going to venture into Canis Venatici, as Charles already visited here a little bit ago. But we're going to make our way up there, and our next stop is going to be NGC 5466. This is a globular cluster, so yay, we're finally into something other than galaxies in the springtime sky. Got a globular cluster, 5466. This is nicknamed the Snowglobe Cluster or the Ghost Globular Cluster. It's class 12, so it's quite sparse. So it's got a very low density profile. There you can see a sense of it here. So it almost resembles more an open star cluster than a globular cluster. And what's neat about this one is that there's evidence to suggest that it may have plunged through the plane of our Milky Way galaxy within about 50 million years ago. So that's a neat thing to think about when you're looking at this one. Because it's so sparse, it's not particularly bright, so it's going to be one that's better suited for a larger aperture telescope, perhaps a 6-inch or larger aperture telescope. Discovered by William Herschel back on May 17th of 1784, number 9 in his class 6 objects. And to find it, you can form an isosceles triangle. Let's see if I can find this. Wind back so you can see a little bit better. Isosceles triangle northwest of Arcturus and Izar. So you can see here we've got Arcturus, the bright star. We've got Izar, the nice double, and it more or less would sit at the vertex of an equal triangle with those two bright stars. The way I found it was another way you can do it is you can connect the line from Vindiamatrix, which is this one, and I connected that up to Neckar, which is at the peak of the kite of Boötes. So it's kind of on that line, but not in the center of that line. It favors the northerly end of that line. The way I found it was I started at the star Rho and I star hopped following patterns around to the globular cluster. So this one, if I put it in the simulated eyepiece view, you can see here that's the view at around 65x. You want to don't over magnify the object. If you over magnify it, you could make it so sparse that it's going to be harder to see it. 65 to 100 power seems to be pretty ideal, maybe even 150, depending on conditions. Averted vision will help, and you want to describe its density profile, see if you notice any various star colors within it or star patterns or little asterisms inside it. Any of that helps to log that. That's about 52,000 light years away from us. All right, now we're going to head into the hunting dogs. And so you've got your two prime, markers is your double star Cor Caroli and your other star Chara. So first up, I'm going to take us to Caldwell 29. So there's a 2-for-1 here. You've got two of the finest NGCs, both occupying the same field of view. They're about 3.5 degrees to the sort of east-southeast of Cor Caroli, but on a June evening, you're going to be looking to the upper left of that star. You can also, if you want, try to just sort of take the line from Chara to Cor Caroli and go about 2/3 of that distance, and then nudge your way up a little bit to find that as well. Now, let's zoom in on it. 29. Here we go. So 29 is another one of these showpieces. It's a nice, tightly wound oval. The density of this galaxy actually makes it observable potentially in big binoculars if you've got a dark sky. Stephen O'Meara, who has superhuman eyes, says that he saw it in a 10 by 50 pair of binoculars. Let us know if you can. Definitely any size of a telescope should be able to show it to you. Discovered by William Herschel back on May 1st, 1785, number 96 of his class 1 objects. And as I said, it's pretty easy to find by using the 2 stars in Canis Venatici. If I bring up the field of view here, I'm going to just give you back the full sort of 1.5 degree view. So there's both of these 2 galaxies occupying the same field, and this magnitude 6.5 field star as well. So this can help you confirm you're in the right spot. So this is one you're going to, again, try to use your averted vision on. It's going to, you're going to be able to describe its shape, its orientation. And if you've got a bigger telescope, you might even be able to start teasing out some internal structure. It's not just a uniform, oval. You might even be able to see some hints of these dark lanes as well inside of it. All right. This one's about 50 million light years away. So now, NGC 5033 is another one of these neat treats. This is nicknamed the Waterbug Galaxy. And you can sort of see why. It's got this neat kind of arms that extend out. Obviously, the core, as you can see, is very bright. So the core is quite accessible in small aperture telescopes and even potentially also in binoculars. So you might be able to get those 2 little fuzzy patches at the same time in your 10 by 50 binoculars from a very dark site. If you've got a larger aperture telescope, you can start to tease out, the little knots, concentrated knots of star formation in the arms, and maybe even start tracing out some of these arcs if you've got good sky conditions and a big aperture telescope. Again, that's another one that averted vision is going to help for as well. And then at the other end of Canis Venatici, we've got the box galaxy, Caldwell 21. And by the way, at this one, if you're kind of heading towards it from Chara, you're going to encounter the cocoon, which we talked about a couple of weeks ago. That's the, as Charles mentioned, was the rhino and calf galaxy. So if you're sort of star hopping from Chara, you're going to catch the cocoon along the way here potentially. But you're going to head on to Caldwell 21, or the box galaxy. This is a small high star forming dwarf galaxy. It a bit resembles the Large Magellanic Cloud in its form. It has a bright rectangular core, and then you've got some sort of tendrils that extend out from there. Again, folks have claimed to have been able to see its fuzzy patch in big binoculars under a dark sky. Really any aperture of quality telescope should be able to pick up at least its core. This one was discovered by William Herschel back on April 27th of 1788, and it's number 213 of his class 1 objects. So I found it by, it's 3 degrees to the northwest of Chara, or about halfway to Messier 106. So if you can find Messier 106, it's about midway between Chara and that galaxy. Well, the other way you can do it is to star hop via the cocoon galaxy to this magnitude 6 star 4, Canis Venatici, or Canum Venicatorum, and then do a right angle. It's that same span, but at a right angle. It's kind of to the north from there. So there's a number of different ways of getting to it. Once you've got it, you probably want to use something like, let's go back to it here. There we go. A little bit small for low power, but if you want to crank the magnification up to, say, 150 or 100 to 150 power, then you're going to be able to start to see its shapes. You want to use that averted vision again, look at its orientation, its shape, maybe sketch out or remark on the various little knots of brightness that you can see. This one's about 13 million light years away. All right. Now we're going to head a little bit north now. We're going to go into the other side of the dipper's handle. So we're kind of heading towards Polaris area, kind of facing more north instead. NGC 4605 here, also known as the Faberge Egg Galaxy or the Frankenstein Galaxy. Again, there's no picture in Stellarium, so you need to bring up your DSS button image here. This one reminded me of the Whale Galaxy, you know, that sort of oval but not symmetrical end to end. So it's a peculiar dwarf galaxy. It's relatively small in size, but it's got a bright concentration to it, and its edge-on orientation makes it accessible to again, perhaps see in big binoculars and definitely any quality telescope. Discovered by William Herschel back on March 19th of 1790, number 254 of his class 1 objects. It's located near the Dipper's Bowl. So let me just bring the stars back here. So if you find the Big Dipper's Bowl, you can make a triangle above the handle of the Dipper from Megrez and Alioth, and it's about an isosceles triangle distance, you know, towards Polaris. So that's the orientation you're going to be looking for. Also, I believe M40 is on the way. So if you're going to star hop from, say, Megrez, you're going to pass by Messier 40 on your way to that galaxy as well. All right, let's put it in the telescope view here. There we go. There we go. Again, averted vision, you want to use different magnifications to see what sort of details you can pick up. You probably will notice a stellar core, you know, a bright central region, and then various amounts of the halo around that. So different regimes of concentrated light as you head away from the core of the galaxy. That's where also a larger aperture might let you see a bit more of the extent of the galaxy. Once you get there, it's you know, once you've got the bigger aperture on it and you've got about to this point, you're not going to really see it get any bigger than that. This one's about 18 million light years away. And next up, we're going to venture into Draco, and we're going to revisit something that Charles already mentioned here in a second. First up, we're going to go to NGC 5907, which in Stellarium is labeled as 5906. This is the Splinter or Knife's Edge Galaxy. It's another really cool showpiece galaxy. It's a large spiral, almost precisely edge-on with a dust lane. It's best seen, though, in medium-sized and aperture telescopes, so 4 to 6 inch aperture telescope or greater. Discovered by William Herschel back on May 5th of 1788, number 759 of his class 2. Just think about how many of these objects he discovered. These numbers are crazy, 750 in this part of his list. Now it's labeled NGC 5906 in Stellarium because Lord Rosse, back in the day, he thought that he saw a strip of this galaxy that was on the other side of the dust lane, and so he assigned a second, basically a second feature to it, or second object to it, and that then got sort of folded into Dreyer's finest NGC catalog, and so it ended up with sort of dual name here. It just barely shares the field of view. Let me just bring this up and bring the field of view down to low power here, and I'll bring up. You can see that there's Messier 102. So if you're familiar with how to find Messier 102, I think we can just barely get them in the same field of view. Now, where it is exactly is if you face north on a June evening, it's basically located just 2.9 degrees to above or celestial south-southwest of the bright star Edasich, which is Iota Draconis. And you're heading, you want to make sure as you're heading towards Segenus and Melotte when you're doing that sort of motion. You know, things rotate around the pole, so things can get a little confusing orientation-wise. Another way of finding it is I doubled the span. Just bring up my measuring tool here. I doubled the span from Polaris to the end of its bowl, and that lands you basically in the right spot. So that's from Polaris to Furcad. We'll get you there as well. So you want to use various magnifications on this one. Let me just bring this up again. Put it in the eyepiece. You're going to be able to see it longer, elongated if you've got a bigger aperture telescope, but you want to describe its shape, its orientation, the profile of its shape. The dust lane could affect the symmetry and the shape that you see, so you want to make a note of that. And there are mentions that you might be able to see some sort of knots of brightness or some variations in the brightness along the plane. So you want to do that. And don't forget Messier 102 while you're in the neighborhood. So this is about 48 million light years away. Next up, we've got the Lost in Space Galaxy. So we've got two finest NGCs to mention here in the curl of the neck of the dragon. Again, we're facing north on a June evening. And first one up here is NGC 6503, also known as the Lost in Space Galaxy. This one's pretty small, but it's a bright dwarf spiral galaxy. It's got dense, tightly wrapped arms. That's going to make it more easily visible in a smaller aperture telescope. So it's worth giving it a try. It's not a Herschel object, though. It was actually discovered by German astronomer Georg Friedrich Julius Onwer Arthur von Auwers in 1854. He only used a 2.6-inch refractor to find it. So if he can find it, I'm sure anybody else can find it. It's about 38% of the distance from Alcon, which is this star Chi Draconis, towards Aldebaran. I don't have all these pronunciations, Charles. Just help me out if you know a better name. Or Zeta Draconis. So it's about 38% of the distance along it. And what you can use to help you is to pick out these other, magnitude 4.5, 4.75 stars along the way. What I did is I actually I'm just going to do this, Control B. I basically put my Telrad with this Zyban and Aldi star kind of on the edge of the rings, and then my finder was basically where I needed to be. So you want to use averted vision, you want to note its shape, its size, and any of the field stars that you might see around it. And you might even pick up some internal structure if you've got a bigger aperture telescope. This one's about 20 million light years away. And last up, we've got one that Charles showed a little while ago. That's the Cat's Eye Nebula, also known as the Snail or the Sunflower Nebula. I think we're getting into some multiple namings of some of these objects here because, as you'll see here in a second, we've got some neat internal structures that give it that sort of two snails snuggled together or something like that going on. It's got an inner envelope that's bright, that's more easily to see in a smaller telescope. But if you've got a big aperture telescope, try to check out and see how much of this bigger outer halo that you can recognize. That's going to need a very dark sky and a very big aperture. In fact, one patch of it is bright enough to have earned its own IC catalog number, IC 4677. So don't just stop when you've seen the planetary nebula itself, but check it out and see if you can see any of the little faint patches around it. And where it's located, so just wind back here. Again, it's in that neighborhood where you just were, an NGC 6503. So what I said, it's about half a degree south of the midpoint between Altae here and this one. So sort of cross the neck, but then you want to head offset about a degree or so off to the side. I also had it noted you could aim your finder midway between the Mag 5 stars LD. Where's that one? This one. And this one. So that'll put you right on the line. So you're talking about this magnitude 5 star, 36 Draconis, and Omega Draconis on this side here. Definitely try an oxygen 3 filter if you have it. That'll brighten up the planetary nebula with respect to the other stars in the field and help you identify a little bit better. Prepare to use lots of magnification, whatever your sky conditions will permit, because the more you zoom in on it, the more potentially interesting details you're going to pick up inside of it. Let's just look at the DSS image and see what we see. Yeah, it's not as good. So your mileage will vary as according to, you know, how much of the detail you can see inside. See if you can see the magnitude 11 central star, and see if you can get the blinking planetary effect to work, where you're sort of using averted vision on the envelope and then direct view of the central star, and you should get a blinking effect going on as well. So that's the list. Hope everybody has some clear skies and good luck and can check out some of these. And if there's any questions, happy to take them.
Wonderful. Don't have any. Well, there is somebody here saying, I think my next star 4SE would be too small for these, but I will try if I'm in the dark sky.
Yeah, actually, that also makes me think of another point, is that don't necessarily judge based on how it looks in your app or in Stellarium, because not the quoted magnitude values in Stellarium, for example, are not always reflective of the true brightness of some of these objects. So if you do look at some other sources, then you can get a better sense of really how achievable it is or how observable it is for you.
Yeah, Charles Messier's original telescope was a 4-inch. And so if you got a 4-inch, I guarantee your optics are better than what they had back in those days. So you should be able to have no problem with any of the Messier objects, that's for sure.
Yeah, yeah. And also if you can get to a dark sky site and you don't have any smoke bothering you, because smoke will affect it. So if you do have a smoky forecast, don't be surprised if you can't see as well some of these objects, because they will extinct it. They'll be
like
extincted.
Local dust lane.
Yes, yes. Well, that's great. So if there's no further questions, we can knock it off early today and
Okay.
and retire. I'll be back in a couple of weeks. I'm planning to cover the whole session on star charts, how to use star charts, how to read them, maybe some of the better atlases than others, and some of their pros and cons, and just some advice for using star charts at the telescope eyepiece. So I think that'll be a good one.
I encourage some of the ethno-astronomers out there to come and take that class, because it's amazing how many errors they make, mistaking gammas for lambdas and this sort of thing when they're trying to use star charts. So that'd be good.
Yeah, it's important to have it right way up.
Yeah, absolutely.
All right. Well, all right, everybody. Well, keep looking up and good luck, and hopefully we can get some fires under control out west and up north, and have a good summer.
Be safe out there.